Hello all, welcome to my channel. Uh, we are back with another video. In this video, we will be looking at some of the Spark execution engines, which acts as an accelerator to Spark jobs. So let's get started. So accelerators, what do we mean by accelerators? Before we see accelerators which are there, let's have a look at the challenges which are there with the current system which is there. So with the improvement in the disk area like SSDs are becoming faster and faster every day by day. Network speed and disk IO also is not that much of a bottleneck today in distributed computing because disks are getting faster, disk IO is getting faster, networks are getting faster. Like earlier, we used to have 1 GB connection. Now in AWS, we even get 25 Gbps connection. So 25 Gbps a connection as a network device is a very great number. So we are not blocked by the amount of data that needs to go from one place to another. We are now the bottleneck is CPU and memory at times because we can't have infinite memory. So Spark's current JVM based engine or code gen design suffers from these challenges, which are CPU and memory linked, not on disk linked. So let's say what happens is Spark will have GC overhead, whole stage gen, code gen has limitation linked to the restrictions of JVM. JVM does not support fully the single instruction multiple SIMD calls, which I think it does from JDK 21, but till JDK 17, which majority of the Spark environments are built as of now, they don't support full SIMD directions. And issues with AVX instruction set also is not there in JVM, which we can use to leverage in this case in Spark to create the accelerators. And this is what people are doing to overcome the challenges of challenging or organizations have started to build native engines. Native engines means which does not leverage JVM. They run on the system kernel. In case of Linux or in case of any other environment, I'll just say so these native engines do accelerate the computing performance of Spark. They do not use the JVM or the Java Virtual Machine runtime to run the processes. So there are a few accelerators out there in the market, like Gluten is one, which is based on Facebook's Velox engine. It is written in the C++, and Intel and Facebook did the initial work for this. So Velox is from Facebook, which is now renamed to Meta. So uh, Velox engine is contributed by Meta, and the Gluten project was initiated by Intel. So yes, that is where this Gluten with an Velox engine is open source, and it supports Calibon, which is the shuffle service we discussed in the last video. Then again, there is one other engine called Gluten with ClickHouse. Again, it is written in C++, and ClickHouse teams found ClickHouse as well as Yandex is the supporting vendor for not vendor, but I will say the major contributor for this project for this native engine, which is Gluten plus ClickHouse. I had some reservations with Gluten on ClickHouse engine because I tried running it in my previous company and I was not able to make it work. It had some loopholes. Gluten with Velox worked fine. It worked straight off the box. Only one or two places I had to make changes in the Spark code base. I was working with Spark 3.5, and to make it work with Gluten, I just have to report one or two PRs in open source community, which was causing issues. Otherwise, it works straight out of the box. No major changes are required. Then we have Datafusion Comet. So this is built on the execution engine called Datafusion, and it is completely written in the Datafusion engine is written in Rust. And the initial work was done at Apple, and then it was later on open source. So now again, it is being supported by open source Datafusion community. This project is very interesting. There are a lot of projects which are now being built on top of Datafusion. Just to give you an example, influx data, which is an time series database, is leveraging Datafusion a lot to build their systems. There is a company called Lake Soul or Lake Fusion. I think it's Lake, sorry, not Fusion or Sail, Lake Sail, SAIL. They are building Spark alternative on Lakehouse using Datafusion. So Datafusion is something which is very much interesting project, which is good to look, and that's why I also prefer Datafusion Comet as one of the accelerators. Uh, Although I have mentioned Blaze, Blaze is not an accelerator. It uh, per se it is itself now becoming an engine, but yes, in initial days, this Blaze, which is built by Quai, again they use also Data Fusion as their own engine, and this also supports Comet and Calibon and Unifil, both is supported if you are using Blaze as a uh, accelerator. I think Blaze is also now in the process of merging it with Apache community or maybe Datafusion. Some discussion was going on that it can be merged with Datafusion Comet maybe. So we'll see how it goes. Rapids is an engine built by NVIDIA. It is written in C++ based on CUDA. The only thing, the problem, not a problem, but an point to note is to use Rapids, you need GPUs. So what it does, it offloads the work of CPU to GPUs, and hence it gains the performance. But it has a downside of needing GPUs to be available. Photon, again, it's an accelerator from Databricks. So this is closed source. This is not open source. This is completely inside Databricks environment. But we know that what they have done is they have rewritten the Spark code base to C++, and that's where they gain the performance benefits. But one thing to note, it is only available in Databricks runtime, not anywhere else. There is a company called Zunai. So Zunai is again some they use the concept of DSL, domain specific language, and they have written their product in C++. What they do is to what they are doing with this project is they are writing a domain specific language to fuse the steps into a vectorized kernel and also do shuffle enhancement. So they also offload Spark engine's work to native engine in C++ and then gain the performance. There is one more project which is kind of not that it's highlighted as of now, which is Windjammer. So this was also a native engine, which was, I'm not sure how it was written because their source codes and everything is not available. It was for data lake solutions where it was optimizing Spark workload to accelerate the processes of calculating sequels or doing aggregation and stuff like that. So this was also one project which was there. Uh, in detail, we will see each of the engines, what they do and what not. But just to keep in mind, if you are in Databricks, you can simply enable Photon. If you have access to GPUs and cost benefit, and after a benefit analysis, if you believe giving Spark jobs access to GPUs and running it in shorter time makes sense, then you can go ahead with NVIDIA's Rapids. And if you have teams or engineering resources which can manage open source code bases and make changes in that to work with your system, then Gluten with Velox or Datafusion Comet can be another good option to look at. But if you are, let's say, startup, or let's say you don't have that much of engineering resources to manage different distribution of an open source environment, Jonai is something which I like. In a sense, we don't have to do much of a work in here. Support is provided by the company, and they have some models. You can decide on the model, on the pricing and all. But their product is also good. They also reduce the run times. They are also actively working on making it compatible with all the Spark APIs out there. So yeah, Jonai can also be a good option if you don't want to have to manage a new system altogether. Uh, Photon, again, as I mentioned, it uses SIMD. which is single instruction multiple data. So instead of, for example, let's say if we have to add 2 plus 3, let's say we had multiple things. Let's say we had a list of, we had, for example, let's say two arrays that we want to merge. For example, 2 plus 5, 2 plus 3, 5 plus 2, and 1 plus 0. So in SIMD environment, or how Spark will behave as of now, is it will call this plus operator thrice, one for each of these. But in case of single instruction multiple data, this whole array will be this is will be taken as once, and also this plus operator will be called once. So this removes the process of number of CPU cycles, because each operator call will require one CPU cycle. So this is how one example how it does improve on uh, the Spark's native code base. For example, instead of using pre-compiled, it uses CodeGen uses a tree approach where which is unpredictable, and we need a custom telemetry to get to see the visibility of what is happening. It is very hard to debug, but what it does, it come it in case of Photon, it uses precompiled kernels, which are deterministic, and we can do a faster testing as well. So this is how, again, one more thing. So this way they have implemented few things in Photon to make it more efficient. Also, what it does, it simply takes the Spark plan, converts into Photon plan, and this talk happens between the JVM and the native engine of C++ via GNI, which is Java Native Interface, and they convert the plan to a Photon plan. For example, output shuffle, and file scan. These are the nodes in Spark plan that gets translated to transition, shuffle, and adapter. What you called Photon plan, and that's how they uh, do the what you call improvements. Like they can do shuffle based distribution, they can do sort merge plus hash join, they have unified query optimizer. So these things helps us in reducing the runtime. And how we enable it, we simply say there is a checkbox in our runtime. So as you say use Photon acceleration, the cost increases, but yes, your jobs will run faster. And this is an architectural comparison of Spark versus Photon. So traditional Spark, it reads data, input data sources, creates a JVM runtime layer. It does a row-based processing. It has memory management, and then the query is executed. While in terms where it comes to Photon engine, input data source is same, but it does not uses any JVM runtime layer. It uses the C++ execution layer. There is no JVM overhead in there. Direct hardware optimization happens. So here, and then instead of row-based, it does a vectorized processing. So single instructions, multiple data operations are executed. So the CPU utilization goes up. Then we have memory management. So because JVM is managing, doing the garbage collection, serialization, overheads, everything is there. In this case, there is no memory. Means zero copy memory is used, no GC pauses, and memory reduction happens. Query execution, again, it is a standard optimization, and latency is baseline. If we take one, in case of optimized execution at Photon, the runtimes are very low. So if you see total summary, the performance summary is like what Photon claims, that if you run the same job in Spark versus same job with Photon engine, you will see 3 to 7 times faster query execution, 40 to 50% less memory, and 80 to 90% of CPU utilization, which earlier was around 60%. Then this gluten. Gluten is again, as I once said, it was done by this. We have already seen that Intel is doing that funding. They incubated this. Now it is open source project. It has two engines, one for Velox, one for ClickHouse. The structure is, again, they convert the Spark plan to substrate plan. Either it can be Velox or it can be ClickHouse, and then data exchange between these happens over Arrow. That is again an in-memory format that has less serialization overheads. And again, this also uses JNI API to connect. So if you see, something will be common, like JNI will be common, everywhere it is used. So some languages use substrate, some languages use the whole rewrite process. So yeah, this is how Gluten works, and it will again the native space memories are given in here. This was the JVM space. So these were different things that were being done earlier. And if we want to install as a Docker, we can do it. The Docker compose file is there. Or if we want to use directly as an image, separate cluster, sorry, separate binary, we can do that. So what we do is we simply, if we are running on Kubernetes, we can put this jar in the Spark environment, home, both client as well as on the master and driver. And if we are using Yarn, we will have to put this separately, like on the all the clients that we build the Spark jar, then only we'll have to put that and then distribute accordingly. Datafusion Comet. So as I mentioned, it was started at Apple, later on open source, made it an open Apache project. It is based on the Datafusion engine. No need to make any code changes, but that is true for Gluten as well. We don't have to make any code changes. Even for Photo, there is no code change needed. Uh, so without any code change, we just get a binary. We just put that binary into the Spark's home directory as well as in the Spark client, and we mention the plugin that has to be used, and then what it will do, it will take this drive, what you call Sparks physical plan, and then convert into Comet physical plan, which is Datafusion Comet physical plan, and then that physical plan is passed to Apache Datafusion, and Datafusion executes it and then returns back the response. So this is how uh, Datafusion Comet works. And again, it's also the same thing is happening here. Like this is the JVM path, and this is the uh, native path, which Datafusion runs with. So again, because it runs on native engine, it has SIMD and column expression. CodeGen also is not, which was earlier very expensive in this JVM path, now becomes very easy or less costly. And also data is shared in Apache Arrow columnar format. So that also helps with serialize and deserialize and overheads. Performance gains for Datafusion Comet. So we have run TPCH 100 GB and TPC-DS 100 GB. So we have seen improvement more when it was with TPC-H 100 GB file with single executor. But TPC-DS not much, I will say. But yes, still the improvement was there. And again, to build this jar, you can download this jar from Datafusion open source library, or you can build this jar locally. And then, so to building this, for that you have to do and release, make release profiles. You say which Spark version you want to build it. Once you have the jar, you can simply pass it, like you can say the SQL extension and the shuffle manager. And once this is there, you also pass the jars. And then when you run this time, the job will runs faster. Blaze, which is based on again Datafusion itself. So if you compare with Gluten, so Spark's physical plan goes to Blaze as well as Gluten. Gluten uses substrate model to execute on Velox or ClickHouse. Uh, Blaze does with protobuf, which is and it runs on Datafusion engine itself. So it is, but that thing I was mentioning, that it is not a plugin; it's a complete runtime, and it requires more significant changes, but it supports Scalabon. So that's it. That is one good thing, and again, it is open source. This is how the flow will be. For example, this is the Sparks data plan, and this will be the native plan. So scan table, filter, aggregate, shuffle, and this side we have second table, which is getting scanned, filtered, and then shuffled. And then we are doing a sorting, then we are doing sort merge join, and then we do collect. What happens in this case is scan table, this remains same, but instead of shuffle, it will do a native shuffle, like zero copy data transfer. Then it will do a native sort merge, and then it will convert to unsafe row. So if you remember in my videos, I have mentioned that Tungsten uses an unsafe row, which does not require that much of memory serialization, deserialization overheads. Same approach is being used in here. So it converts the rows into unsafe row and then does the collect limit. So this improves the whole process. Again, it also uses arrows foreign functional interface to achieve this call for a different language. Installation, again, it is something similar to how we do it with Datafusion. You pass this information that which mode you want, then you build this package, or you can download the jar. And once you have the jar, you provide the extension, which is the SQL extension, and the supply manager as well. And then you can run. As I mentioned, there are some notable proprietary accelerators like Zonai or Windjammer. This is the decision graph that what you want. For example, Spark accelerators, there are two. One is hardware based, another is software based. So hardware based, there is only as of now one option, which is called NVIDIA's Rapids, which requires GPU. Then software based, we have two types. We have proprietary or open source. So proprietary are Jonai and Photon. Jonai is from a Jonai company named Jonai, and Photon is from Databricks. Open source is Datafusion Comet or Blaze, and if we need multi-engine, obviously like Datafusion Comet and Blaze does not support any other engine. Like for example, it only supports Spark as of now. But if we want multi-engine, Gluten, which can be used with Flink as well. So yes, we not sorry Flink. I'm saying we have multiple engine option to run it. For example, if we want, we can run it with Velox. One we can run it with. ClickHouse. The reason this benefit is there because each engine's cadence cycle will be different. They might be doing their what you call porting or making this a Spark to their engine specific what you call compatibility in a different what you call velocity, and hence whatever is covering the most of the APIs you can use those. For example, Gluten plus Velox supports more than 80% of the Spark APIs, while Comet, as of now, I think it is at around 70% of the API completely. Jonai has higher because I think it is around 90% of API compatibility. Photon will have everything as it is complete rewrite. So yeah, based on that, you can decide which. I mean, based on many things like which platform you are, which ecosystem you are already in. So which one will make sense, and that's how you can choose it to work on. So yeah, this was it for these Spark accelerators which are there. So this image will help you as an what you call just a refresher of what we have talked. Like we have engines like multi-engine accelerators like Gluten, which supports both Velox and ClickHouse. Then we have projects based on data fusion like Comet and Blaze. We have proprietary solutions like Datafusion, Databricks Photon, or Zonai. So yeah, based on your use case, you can choose anyone. I hope this video was useful. If yes, do share and spread the word. Have a nice day. Bye bye.